Hi everyone! In today's video, let us know to check for faults and test the electrical and other system components of a refrigerator. Objectives: at the end of this video, you will be able to Number 1. Check and test the current coil relay. Number 2. Check and test the overload protector. Number 3. Identification of compressor winding terminal pins with an ohm meter or test lamp or clamp meter. Number 4. Check the short circuit in the compressor. Number 5. Check the condition of a door switch. Number 6. Check the thermostat. Number 7. Check the capacitor.
Let us collect the tools and equipment to do this exercise. Screwdriver 10 mm tip, 200 mm length, 1 number. Cutting plier 200 mm, 1 number. Nose plier 1 number. Phillips screwdriver set 1 number. Ohm meter or multimeter 1 number. Clamp meter 1 number. OLP overload protector 1 number. FHP fractional horsepower compressor 1 number. Test board fitted with voltmeter and ammeter 1 number. Capacitor 1 number. Sandpaper as required. Insulation tape 1 number. Procedure: Task 1. Test the current coil relay. Step 1. Check continuity between the 4th and 5th with the help of ohm meter or multimeter. Step 2. If the continuity is okay between 1 and 2, coil continuity of current coil relay is okay. Normal condition 4 and 5 continuing will be there. Step 3. Check continuity between 5 and 6. Normal condition when not in use, 5 and 6 open. If there is no continuity between 5 and 6, relay is okay. Step 4. Keep the relay upside down. Check continuity between 5 and 6. If the continuity is there, relay is okay. Step 5. Bring to its original position. Check continuity between 2 and 3. If there is no continuity, relay found okay. Step 6. Check plunger movement and observe sound. Keep the relay upside down. Plunger moves up and you can hear the sound. Bring to normal position. Plunger comes down. You can hear sound. If there is no sound, relay is defective. Relay plunger operating is not okay. Task 2. Check and overload protector. Step 1. Check continuity between 1 and 3. Step 2. If the continuity okay between 4 and 5, continuity of bimetal contacts okay. Step 3. If there is no continuity, overload is defective. Step 4. Check any rust formation in disc. If rust formation is there, not advisable to use. Task 3. Identification of compressor winding. Terminal pins with ohm meter or clamp meter of fraction horsepower pneumatic compression. Before carrying out the exercise, remember the following. Running winding resistance always less than starting winding. Starting winding resistance always higher than running winding. Resistance of run and starting winding, sum of starting winding resistance and running winding resistance.
Set your multimeter to the resistance ohms mode. Touch one multimeter probe to one of the motor's terminals and the other probe to one of the remaining terminals. The terminal that shows the lowest resistance to both other terminals is likely the common terminal. This is because the common terminal is connected to both windings, and measuring across it will show the combined resistance of both windings and note down the readings.
Step 1. Set the ohm meter in resistance at low range. Step 2. Measure the resistance between A and C, 20 ohms. Step 3. Measure the resistance between A and B, 40 ohms. Step 4. Measure the resistance between C and B, 60 ohms, and record the values in the tabulation. Step 5. Identified A terminal pin becomes common terminal. Step 6. Identified B terminal pin becomes starting winding. Step 7. Identified C terminal pin run winding. Resistance values slightly vary from manufacturer to manufacturer. Instructor must have compressor manufacturer specification. Task 4. Check short circuit in compressor. Step 1. Check the multimeter to resistance mode at the appropriate range. Step 2. Place A probe to compressor terminal. Step 3. Place B probe to metal casing of compressor. Step 4. Check continuity. If continuity is there, compressor grounded. Step 5. If there is no continuity, compressor not grounded. Task 5. Check the condition of a door switch. Step 1. Switch on the refrigerator. Step 2. Open the refrigerator door and check the condition of cabinet bulb. It should glow. Step 3. If it is not, check the bulb. Step 4. If the bulb is fused, replace the bulb on refrigerator and check. Step 5. Still the bulb not glows, then switch off the refrigerator and remove the door switch and disconnect the wires. Note: mark all connections which are being disconnected. Step 6. Check the continuity in switch by multimeter or by test lamp is on and off position. Step 7. Check bulb holder wires. Step 8. If switch found defective, replace it and connect wires. If found necessary, add salt and ice cubes from time to time. Take out salt water from the insulated container from time to time to obtain correct temperature. Precaution: while handling the thermal bulb, do not bend the capillary too sharp as it may break. Task 6. Carry out a test on thermostat. Step 1. Crush ice cubes and place it in an insulated container. Step 2. Mix some salt to the crushed ice cubes. Step 3. Insert a thermometer inside the container. Step 4. Take a thermostat and check electrical contact points. If necessary, clean the contact points with fine sandpaper. Step 5. Connect 2 wire leads to the thermostat. Step 6. Connect a bulb in series with thermostat. Step 7. Connect the other end wire leads with 2-pin plug and plug it in test board and switch on. Step 8. Check that the light glows when the knob of the thermostat is not in stop position. Step 9. If the light is not glowing when the knob of the thermostat is in stop position. Step 10. Adjust the knob to on position. Step 11. Watch the reading of the thermometer. Step 12. See that the 100 watts bulb glows all the time. Step 13. Wait till thermostat goes to cut off, which will be indicated by off position of the light. Quickly take the reading of the thermometer. Step 14. Remove the thermal bulb from the ice cubes. Step 15. Hold the thermal bulb by hand and warm it when the thermostat goes to cut in position, which will be indicated by the glowing of the 100 watts bulb. Step 16. Note the temperatures for 3 different readings carefully and record in tabulation.
In a single and dual door refrigerator systems, a thermostat is present. In a 3 and 4 door refrigerator system, a thermistor will be present on the PCB board. Start by visually inspecting the PCBs for any signs of damage, such as burn marks, discoloration, or corrosion. Check for loose or damaged components, connectors, and solder joints.
Task 7. Check capacitor. Caution: do not place fingers across the terminals of a capacitor. It may be charged and gives a shock. Short it with an insulated wire before handling. Step 1. Remove the capacitor for test. Step 2. Connect the capacitor in capacitor test circuit. Step 3. Check the fuse D in the circuit as shown. Step 4. Switch on the circuit plug E. If the capacitor does not take a charge, it will not spark. This indicates an open circuit. The capacitor is connected to the terminals of the tester. Step 5. Press the charging switch B for 1 or 2 seconds. Step 6. Put off the circuit plug E. Step 7. With the switch open at B, touch the shorting switch C. If the capacitor is good, the switch will spark. Step 8. If it does not spark in the first time, try it 2 or 3 times before replacing the capacitor to the unit. Note: If the capacitor is good, it will spark. If the capacitor is shorted or grounded, the fuse D will blow as in view. Caution! The capacitor should be put in a protective case while testing it because a short capacitor may explode when put in a circuit.
Recap. In this video session, so far we have discussed how to check out for faults and test the electrical and other related system components of a refrigerator.